Um, there's a lot of definitions here. The vector, the main thing about a vector, those of you that took physics, okay, it's similar. We do things a little bit differently, but it's not completely differently. Like it's not, we're doing it a different way. It might look different, but it still means the same thing. So a vector, the most important thing to know is that it has magnitude and direction. The magnitude is just how long it is, and you can determine how long it is. We're going to be drawing them on coordinate planes. So when you draw them on a coordinate plane, you're just going to count how far it goes left and right, how far it goes up and down, and that's going to give you the magnitude. And then the direction is going to be shown by the arrow. You're going to have an arrow on one end or the other, kind of looks like a ray. That arrow is what tells you the direction. A scalar is just something you multiply it by. So you're just going to, you can make it twice as long, half as long, 1.5 times as long. That's all that means. Those last three things we're going to kind of deal with the next couple days. So there's some examples of it, just reminding you how to find total distance or how to find the displacement of something, where something is moved to. And again, those last three things, really we'll deal more with those the next couple days, but just so you have an idea of what that means. And if you're not finished with that, I'll go back to it at the end if you need me to. Again, a vector just looks like a ray. It has a dot on one end and an arrow on the other. So the initial point, the dot, you can call that the dot, the initial point, the foot or the tail, has all those words. I usually just say dot or initial. And then the terminal point is where the arrow is. It's called the head. So we have dot and arrow. Initial, terminal. Head or tail, foot. Tail, head, or foot, tail, however you want to say that. Again, I usually use dot and arrow because that's what they actually are. The length, again, is the magnitude. Now, if you printed your own notes, it printed probably nice for you, but for some reason the computer to the printer messed up when I printed it, and it kind of looks like just a solid, big, thick line right there. That is not correct. There should be two little lines on each side of it, kind of like a double absolute value looking symbol there. That is the symbol that we will use on tests and quizzes. Okay, so the little double lines on each side of the vector is the symbol for magnitude. So we could say find the magnitude of the vector, or find and have that symbol right there. So just be sure you fix that on the notes because for some reason it messed up when I printed. And then the last thing, vectors are equal if they have the same magnitude in the same direction. So we could take this vector right here and move it wherever we want, as long as it stays the same length and it stays the exact same direction. The degree measure doesn't go off by even a tenth of a degree. If it's the exact same direction, then they're going to be equal. You can move them wherever you want. All right, how you write vectors. So this first one, bolding is only for typing. You cannot write in bold. You cannot give me a note and say that you wrote in bold. Okay, I'm not going to accept that. You can have a bold lowercase letter. Again, that's only when it's typed. These are the two ways that you would write it. Either the vector is given by a single letter. That single letter you would write lowercase with either the arrow, full arrow, or half arrow over it. I usually choose the half arrow. I don't know why. That's just what I pick. But you can do a full or a half. If you're given an initial and a terminal point, this is point A, this is point B, then you would start with your capital letter of the initial point, capital letter of the terminal point, and then again the arrow or the half arrow over it. It's up to you. It kind of depends how the problem is given, and that will determine which of these you use, either lowercase one letter or uppercase two letters. And then again, vectors can be moved wherever, and they can still be equal. Okay, operations. We have add, subtract, and multiply. We really don't have divide because if we divide something by 2, that's the same as multiplying by 1/2. So we don't really talk about dividing of vectors. Addition, first thing is vectors must be head to tail. So right here, this right here describes head to tail. When I connect these right here at letter B. So when I draw them, they must be head to tail. So that's what that example on your notes is. if we want to find the result of those two, which is that's what you're trying to do. If I said what's 2 plus 3, you wouldn't just write 2 plus 3, you'd write what's the result. It's 5. So here the result is this dashed line right here. Notice it has an arrow on it. Starts right here. So we go dot to dot and arrow to arrow. So when you're drawing the two vectors, they must be head to tail. But the resultant is head to head and tail to tail, or initial to initial, terminal to terminal, dot to dot, arrow to arrow. Now, I said a second ago we can move these wherever we want. They can be moved around. So this second example right here, these are not head to tail right here. Okay, these are all initial points are connected. So if the initial points are connected, we can still figure out what the resultant is. It's just going to be different. So if I took this VC right here, which was right there, and I moved it up, so it was here, and I moved it up, I can still come up with the resultant. It just comes out the middle of those dots. So if all the dots are, if the two dots are together, the resultant is dot, and the arrow goes out. I could move this over here. Notice now we're back to normal, head to tail as if I was drawing it, but this could also be down here. Look like that. Now all the arrows are together. So all I did was move those vectors around the resultant, and the resultant stayed the same. It did not change. If you're drawing it, it needs to be head to tail. But if I just said, what is the result from a picture, and there'll be one on our notes, the last problem today gives you a picture and you're trying to determine if things are true or not, that is how you figure that out. All right, so that's adding. And really subtracting is just adding. We always say we want you to get rid of double signs. Well, now the double signs are kind of more helpful. Because here if I have v minus w, if I think of it as v plus a negative w, then I'm still just back to head to tail. So I take vector v, stay the same, and w is the opposite. Negative means opposite. The opposite of 4 is negative 4. So negative 4 is the opposite of 4. So the opposite just means the arrow and the dot change positions. So here's the arrow, here's the dot. So that is the vector negative w. So if I take vector v and I just redraw it, again this, whenever we ask you to draw something, it'll actually be on a coordinate plane as far as the test and quiz goes. And then we add negative w. So here's vector v, here's negative w, there is your result. So when I'm adding, it's head to tail. When I draw the result, it's head to head, tail to tail. So right there, dot to dot, arrow to arrow. And I don't care if you actually put a dot right there, as long as you start at a specific position and you end. Wherever you start and end is going to be important. You can start wherever you want, but your end point has to be a specific length. And we'll talk about that here in a second when we start drawing it. All right, and then the last thing is multiplying. So multiplying is just making it twice as long, half as long, 3 times as long, whatever the number out in front is. Notice that the vector symbol does not go over the number though. Okay, the vector symbol is only over the v. Only over the v. It's not over the number right there. This last one, the 0 vector, 0 is the only number that there will be a vector symbol over. So if it's typed, it can be bolded. If you write it, you have to write it 0 with a half arrow or 0 with a full arrow, however you want to write that. A lot of people tend to do the half arrow because they get confused with this meaning array, but we don't do anything with rays in here, so for me personally, I don't care which one you use, the arrow or the half arrow. You just can't write in bold. All right, so now this first example. Now, you have on your notes 3 separate little graphs. You can do them on each separate graph, or you can do them all on the same graph. It's up to you. I'm just going to do them all on the same graph right here because it's easier for you to see on this bigger graph than little bitty pieces of it. So, we're going to sketch a vector representing a walk of 200 meters on a heading of south 20 degrees east. So, south 20 degrees east, that kind of goes back to the last unit, or the last semester, when we were talking about bearings versus headings. So you have to know a little bit of that in this unit, but not just a ton. You are going to have to know a little bit of the unit circle stuff, but it's very simple stuff that will probably come back to you when we start getting into application problems. So the second question says sketch half of W, and then the third one, negative 2W. So the reason why we have to think about all of them is because when we start, just like when we did those navigation and surveying problems, we couldn't just start in the top left like normal. We kind of had to be strategic about where we started our graph. So this one is south 20 degrees east. So if we go back to that, this is south, north, west, and east. South, and then we go 20 degrees to the east. Now, if we think about, well, where's 20 degrees? Well, we know if we go right out the middle, that's 45 degrees. So I'm going to start right here, letter A. If I went down 1 unit and over 1 unit, that would cut that 90 degrees in half. Well, I don't want to be in half. I want to be 20 degrees. So therefore, when I draw my endpoint, I need to be a little bit less than straight out the middle. So I'm going to say this point right here. I'm going to draw that vector. It's about 20 degrees. It doesn't have to be perfect. It says a sketch, so it just needs to be less than halfway out the middle. It can be wherever you want it to be. You just can't be down, you've got to be less than that line right there, because that line right there would be 45 degrees. Doesn't matter where that point is. Again, you could all have something different and it would all be correct. So that is what we are going to label vector W. So now when we sketch vector V, which is half of W. So letter B, we're going to take this vector and just cut it in half. So we just have to have a starting point. So now is where we're going to count. So 1, 2, 3, 4. I went down 4 and right 2. So if I want to do half of that, that's down 2 and right 1. So there is vector V. Now if your point was 5 and 2, you would go down 2 and a half and over 1. If you went down 7 and over 3, you'd go down 3 and a half over 1 and a half for your new terminal point. It is up to you. Depending on what your first one is going to depend what your second and third is. And we also don't want to make it so little that we can't take half. We don't want to make it so big that we can't double it on the graph that we're given. So then it says describe the trip it represents. Well, we didn't change direction. All we did was go half the distance. So it would be a walk of 100 meters on the same heading. A heading of south 20 degrees east. So headings start with south or north, the degree, and then east or west. We could change that to bearing if we want. Remember, bearing starts north and goes clockwise. You're going to have to remember that for your homework today. Bearing starts north and goes clockwise. So you can be given a heading or a bearing. The only other way it could be written is it could have said 200 meters to the southeast. If it said southeast, then it's just straight out the middle. All right, so vector R is negative 2W. So we're going in the opposite direction and twice as far. So if this direction is down and right, the opposite of down is up, the opposite of right is left. So I'm going to start down here. And again, according to whatever you started yours as, if I went down 4, the opposite times 2 is going to be up 8. And then since I went to the right 2, the opposite times 2 is 4 to the left. So there would be my vector R. Again, however long you made your original one is going to depend how long your B and your letter C are. Those all depend on your original one. And it's going to be important that you make it exactly the correct length. Don't be close. If you're one off, it's going to be wrong. Okay, it has to be exact. So you're going to have a little bit of counting to do on problems like this. All right, describe the trip it represents. So the trip it represents is twice as far. We don't walk in a negative direction. So we're going to have 400 meters on a heading in the opposite direction. So the opposite of south is north. 20 degrees stays the same. Opposite of east is west. Now, if we had said, what is that bearing? Okay, if we change that to a bearing problem, let's think about that. So bearing starts north and goes clockwise. So the bearing of that point, this is still 20 degrees right there, would be 340 degrees. So again, just remember that. There's not a lot of bearing and heading stuff, but there is a little bit just so that you can get your vector going in the correct direction. All right, the next one, it gives you two vectors, and you have to draw the result of those two. Now, first we're going to actually draw what it tells us to, and then we're going to connect them with the actual result. Because again, if I ask you what's 2 plus 3, you're not just going to tell me 2 plus 3. You're going to tell me the result, which is 5. So when I look at this, this is again where we kind of have to be strategic on where we start. We can't just start anywhere because we might run out of graph. And if you're off the graph a little bit by 2 or 3, it's not a big deal. Just draw some little lines in. Don't erase the whole thing and start over. The first thing I would do is look at my vectors that are given and just count them. So here, I would count this as down 1, 2, 3, 4, 5, 6, and 3. Just so I have an idea when I'm drawing them what I'm going to count. And then here, 4, 6, 13, and 5. And it doesn't matter if you go right now, I mean, you're drawing the start and end point, and you're going in straight in horizontal and vertical lines, whether you went over first and up, or up and then over, as long as you get there. All right, so I'm going to draw u times 2, and then add v. So basically, it's kind of set up in the right area right here. I'm just going to draw double the u, and then add it to the v. Because remember, when I add them together, I'm head to tail. So I'm going to start pretty high and over to the right. And so I'm going to redraw u. So there's my vector u. Whoops, 2u. So if I start up high, I'm going to go down to 12, not 6. And then go over 6 by doubling the 3. So there is my 2u. Now, if you wanted to draw u and then draw u again, that's fine also. You can just draw 2 of them. U plus u is the same as 2u. All right, then I'm going to draw the vector v. So I'm going to go head to tail. So my initial point is going to start right here. So I go up 1, 13, and over 1, 2, 3, 4, 5. So I'm a little bit off the graph, but again, that's okay if you're a little bit off the graph. What I'm looking for on this problem is what's the result, okay? So you just drew 2u plus v. The answer to this problem is going to be the actual resultant vector. So resultant vector is dot to dot and arrow to arrow. So the arrows match up, the dots match up, and it has to be a specific length, side to side, up and down, and the arrow has to be on the correct end. The most common mistake I see is forgetting to put the arrow. And if there's no arrow, it's not a vector. Vectors have to have the arrow. Now, if you draw a dashed line, to me, a dashed line means it's the resultant. If you want to go one step further and label that 2u plus v, that's fine. Just be sure that you do that correctly. Don't put the vector sign over the 2. Okay, the dotted line only with the arrow is fine with me. That shows me that you know what the result is. All right, so the next one, u minus v. I like to make that vector u plus a negative V. So I'm still adding, so I'm still going head to tail. I'm just adding something that looks a little different than what was originally given. Remember, all that means is the dot and the arrow switch places when it's negative. So the arrow's down at the bottom and the dot's up at the top. So if I have U minus V, I'm going to start pretty high on this one, and I just redraw U. So that's down 6 and over 3. So there's your U, and I'm going to add negative V to that. So if V goes up 13 and left 5, negative V is going to go down 13 and right 5, or right 5 and down 13, whichever way you want to do that. So from here I'm going to go down 13, and then over 5. And there is negative vector V. Again, my answer is going to be the resultant. When I add it, we're head to tail right here. The resultant is head to head and tail to tail, or dot to dot, arrow to arrow. And those arrows match up exactly. Those arrows are in the exact same point. The dots are in the exact same point. And you could just draw the resultant. I don't have to see both of the original ones given. I don't have to see these two. This is what I'm concerned about. The vector U minus vector V. That is what I'm going to be grading right there, that dashed line. The other two you can draw if you want to. And right now you might need to. And as we move on and we start doing things algebraically, it might be easier to just draw the resultant. And that's fine also. All right, this last problem. So you have this parallelogram, and we got to remember with parallelograms that the top and the bottom are equal, these are equal, and then your bisectors that go through the middle. So those are equal. So these lines are equal, and those lines are equal. So just a little reminder from geometry about parallelograms. So the easiest thing to answer these is to actually draw the problem. So it says vector BC. B is where you start, dot. C is where you end. Initial, terminal, dot to arrow. Plus BA, so here's B to A. And it's asking, does that equal BD? Well, typically when we draw and we're adding, we want them to be head to tail. But remember, we can move these. We can move this green line anywhere we want. If we move the green one up here, we could move this purple one over to the side. Or if we look back at our adding notes right here, this example right here, the dots were all together and we still had the resultant go right out the middle. Therefore, this first one is true. Now, if you printed your own notes, your letter B is correct. If you printed the notes or if you picked up the notes that I printed, go ahead and get rid of that letter B, because we don't have enough information today yet to do that. Again, if you printed your own, it should be okay, but if you picked up my notes, then it was not updated for some reason. All right, so here we have AO is equal to AC. Okay, well, obviously we look at that, that is not equal, so that is false. So we need to make it true. Lots of different ways that you can make it true. It's up to you. The only thing you can't do is say AO equals AO. Obviously, if you have the exact same thing on both sides, they're equal. You have to do something to one of the sides to make it equal. So one thing you could do is you could say 2 AO equals AC. We take AO and we double it, that would work. You could say AO equals half of AC. Lots of different ways that you could go about doing that. There's not always one way. Sometimes there's only one way, but it is possible that there is more than one possible correct answer. All right, here we have AB. So AB goes to the right, plus CD. CD goes to the left. And remember, since it's a parallelogram, those are equal. So whatever their length is, let's just say their length is 10. One of them is 10 to the right, which would be positive. One of them is 10 to the left, which would be negative. So therefore, this is a true statement. Now, if I just said, find that. Tell me, AB plus CD equals what? According to this picture. You go to this picture, here's AB, here's DC. That's going to be equal to the 0 vector. Okay, so another way, I think that's the way on your note, on your homework it's asked. It doesn't give you a true or false. It just gives you one side, and you have to tell me what it is equal to. So that's another way you could be given a picture and have to answer the question. Either true, false, or actually answer what the left or right side is equal to. All right, here we have AO is equal to CO. Well, those are equal in magnitude, but they are not equal in direction. Their direction does not go the same way. So this one, false. Lots of ways to fix it. We could say negative AO equals CO, because that changes its direction. We could say AO equals OC. Another way to fix it. We could say AO equals negative CO. Lots of different ways that you could go about correcting that. Again, the only thing you can't do is say AO equals AO. That's not something that you can change to make it correct. All right, and then this last one. So here's AO, and there's AC. Again, these two segments are equal, so therefore that one is a true statement. AO is equal to half of AC. If we take AC, cut it in half, we're left with half of that. So those are equal. Okay. And then just a reminder again, we talked about a while ago, but remember that bearing